we have that there are 25 items and they can be split up into 3 groups. This is oftentimes what we call a multinomial problem. There are many different groups, more than 2. One with 15 items, one with 4 items, and a third with 6 items. What is the probability that if 5 objects are selected at random, that from the 25, that 3 come from the first group, 1 comes from the second, and 1 comes from the third? Very much like a combination problem. From the 25 items, there are 25 combination. We're selecting a total of 5 objects. That means there are 25 combination, 5 different ways you can draw 5 people from 25. But we want to know the probability that 3 come from the first group. So that's, the first group has 15 items, so 15 combination 3. 1 comes from the second group, so 4 combination 1, times, and 1 comes from the third group, so that's 6 combination 1. So we want to know all the different pairings of the 3 drawn from the first group, paired with all of the possibilities in the second group, paired with all of the possibilities in the third group. So in this case, we would come up with, we are going to hit enter as we have this all entered in, and we get a probability of about 0.206. So 0.206 is the probability that we draw from these groups, and that 3 end up from the first, 1 from the second, 1 from the third group. Now keep in mind, one important note is that the 3 plus the 1 plus the 1, the number of things that we're drawing, has to sum up to the total number of things that we're drawing. Otherwise, we're going to get an incomplete picture. You can't possibly draw 5 things, but then only look for the probability of drawing 4 of them. That doesn't make sense. If you're drawing 5 items, you've got to account for the 5th one as well. In the second problem, pretty similar, except 5 objects are drawn at random from the 25, so there are 25 combination, 5 different groups you can create, that all 5 come from the first group. Is this probability higher or lower than what you found in part A? Why does this make sense? Okay, well, we want all 5 to come from the group of 15, so there are 15 combination 5 ways to do that. Now I guess we would expect this to be higher, because we would say, well, all 5 coming from the biggest group probably makes a little bit more sense than 1 coming from a small group and then another one coming from another small group. So if we just do our repeat enter and just change this 3 to a 5, and I'll just delete some of the other stuff here. Okay, so then we have 15 combination 5 over 25 combination 5, and we get 0.057. Now you can kind of tell how deceiving this is, because we wanted to select all 5 items from the group of 15, and I thought it was going to be higher personally, but you can obviously see that it's a considerably lower. And I guess the argument we can make in favor of that is it's unlikely that you get all 5 coming from just one group, because even though these are smaller groups, these postulate 10 of the 25 elements that we have in this sample. Therefore, we'd probably expect at least 1 to come from one of these 2 groups. Probably more so this guy here. So our probability is 0.057.